So some of the questions that you could have in the back of your mind as you're working, you might come back to this in a few days and just read through the questions again and sort of ask yourself, or like try to answer them or just think about them. They might just help give us some context for what we're doing. What makes something a function and why is this important? Again, I think that's an interesting question. You probably hear about functions by their definition for the first time. You probably heard about them in grade 11. Some schools, they talk about them in grade 10, but I think here you don't talk much about them until grade 11. And so you hear what a function is and how to tell if something's a function, but who cares? Like, why is that important? This is just a weird definition that math people care about and nobody else cares about. But that's not true. That's just, we don't know enough about functions and about the overall purpose of this to be able to answer that question yet. But it is an important question. It's something to think about. Why do we graph or sketch relations or functions? Like, what's the purpose of doing that? We do a lot of sketching in this course. How do we determine the characteristics of a function? Why do we care about functions at all? Not just if it's a function, but functions of relationships. What about growth? Why does the nature of growth matter? And then some skills for this unit, and again, for kind of the whole course, is transformation, sketching with transformations. So again, if you just finished grade 11, you know a lot about that, I think, and you're probably hopefully fresh with that. Looking at a graph or looking at the equation of a graph and understanding the characteristics and properties of that relationship. That's a big one. And relating those from the equation to the graph. So you've done that a lot with quadratics because you start in grade 10. You should be an expert at it by now. But we're going to extend those skills to other areas. Factoring. So we're going to use some factoring, and in a few units when we start doing more polynomial stuff, we're going to do even more, a lot of factoring stuff and extend those skills. Solving simple equations, that's always something that comes up in mathematics. So here I have some pictures of functions. So what I want you to think about, and you can start actually giving some ideas, like these are all different. Don't try to draw them or anything, just watch. What makes one different from another or same as another? How would you describe them? If I asked you to describe your best friend, what would you say? They have brown hair, brown eyes. Today they're wearing a green shirt. They're about 5'11". Like, you would describe their characters, what they look like. Maybe describe their personality. How do you describe these graphs, these relationships, these functions? What kinds of things you say? Does anybody help? Like, first one. What would you say? No right or wrong answer. It's quadratic, good. What does that tell us? Okay, tells us something about the equation. Nice, good, yeah. What else? What are the important, so there you go. What are the important properties of a quadratic? You guys know this. What are they? How would you describe them? How would you define them? Go ahead.
Well, right there is just like a reflection. Like it's
Yeah.
It has different.
Yeah, it's got some shifts. Yeah, right?
The domain can be anything.
Okay, good. So domain. And what does that tell us about the function or the relationship? That the domain can be anything. X is an element of the real numbers. Like, what does that tell us about what's happening? What's the domain of this? X is an element of the real numbers. What's the domain of that one? You don't know maybe a lot about cubic functions, but it's the same. So giving me the domain doesn't distinguish between these two. It's not a matter of being right or wrong here, right? I haven't given you any goal that you're trying to accomplish. But this one does have a different domain. So it does tell me something different. You see, it's just, these are the kinds of things you should be thinking about when you're thinking about functions. How would I describe them? Somebody, go ahead.
Every x value only has one y value.
Right, nice. They are all actually functions, which is what you're saying there. So every input gives you a unique output. That's what makes a function important. Okay? That's like if the bank if the bank records weren't a function, and I gave them my name, and they need to give me back my bank account information, not somebody else's, right? Like that's the important idea of a function, input, output, unique output. Okay, what else? What other kinds of things do we have here?
Use the vertex to
Okay, good. So this one's got a vertex. This one has not a vertex necessarily, but a turning point. So maybe that's something you could describe. It's going one way, it changes direction and goes the other. What does it do? Oh, it changes direction again and goes the other way. This one's pointing up here and down here. These are both pointing down. This one's pointing off to that side. This one's pointing up to this side. Like, doesn't that, just where the ends are pointing, tell you something? Like, that makes these different, right? What kind of a relationship might this represent? Anybody know what a quadratic can represent? Yeah, throwing a ball or an eraser follows a quadratic path, right? Can that one? No. But something else in the world maybe follows that kind of a path, or that kind, or that kind, or that kind. Let's take a look at a couple of these smaller ones. These ones further down. So what's that? Do we know what this one is right here? Yeah, that's a sine curve. Okay, very different from all the other ones that have like endpoints that are going off into one direction. This endpoint goes off this way and will keep going that way forever. It never turns back around. And I know that about a quadratic. And I know that about a cubic and about this reciprocal function. But with sine functions, periodic functions, not necessarily the same. It depends on where you look at it, what direction it's pointing, right? It doesn't have that kind of end behavior. What about this one? Ooh. What could that represent? Hunter, were you having a thought?
Don't know how to describe it, like a pendulum on like a clock.
Yeah, sure. And then it slows down over time and it doesn't, yep. So something swinging back and forth. I mean, there's lots of things that it could, right? Represent its displacement over time. Interesting. I want to show you something else. We're sort of just chatting. Oh, I hope I can find it. There we go. I think this is what we want. GeoGebra. Have you used GeoGebra? I love GeoGebra. If you haven't used it, you should find it, install it, and get to know it. It's a wonderful, wonderful, powerful application. Okay. Let's see. Okay, so just take a look at this sine function. This is interesting. It looks a certain way. What happens if I change the a value? Oh, I'm not going to be able to do it. Oh, there we go. What happens if I change the a value? Sorry. Changes the look of the function, right? So it's changing the amplitude. Maybe some of this is familiar. You don't need to know this stuff right now. This is not what we're learning. But changing the values in the equation changes the look of the function. This is the kind of stuff that we get into eventually. Something that's interesting, though, what if I do this? If I change the scale? That changes the look of the function, too. But I'm not changing the function, right? Do you believe that? I make it look more stretched out, but I'm not actually changing it. I'm just changing the scale. So why do we need to know, what in the world is this guy even talking about? Why do we need to know all of this stuff? Well, looking at it on a graph only helps me so much. I need to know the numbers, I need to know the scale, how they relate to the equation, what that actually means about the function in general. But it's all of that put together. It's the bigger picture of how does the equation relate to the graph? How does the graph show what's happening in the equation? And then doing math like algebra and solving for things in the equation. I mean, that's what this course is about. So let's get to it a little bit. Graph each of the following, state the domain and range. So while we're doing this, think about how these equations give us different functions, or non-functions in some cases, how these equations give us different graphs and have different relationships, and how we would describe those characteristics and properties. Who knows what the first one is? It is a circle. What do we know about the circle from the equation? You don't do a lot of circles, so if this isn't totally obvious to you, that's probably okay.
The radius is square root of 16.
Very good. Which is
4.
4. So it has a radius of 4. So I can start plotting some points like this. And that gives me a sense of kind of what the function does, so I can now really probably terribly, but try to draw a circle. One of the things that is hard about doing it on a computer screen like this, it doesn't give you the same feedback that like a pencil does, so it can be really hard to draw curves and that sort of thing on a computer. But anyway, just so you know. Okay, good. What is the domain and range? So here's how I always, like when I teach this stuff in grade 10 and you first start learning what domain and range is, this is how I try to teach it. So I would encourage you, I don't see any reason why it would change just because you're in grade 12. You want to understand the natural way of saying what the domain is, and then separately, how do you write it the mathematical way with the symbols and in proper form? Okay, so those are kind of two separate things. Some people can write the symbols, but don't know what they mean. Some people could probably state the domain with their own words, but not understand the symbols and how to write it properly. Right? But you want to be able to do both. So what is the domain? Just with your own words.
X is the element of all real numbers, but X has to be greater than -4, but less than 4.
So how would you say that just in your own non-math words?
That was.
It kind of is, but you described it. I mean, it's very good. So you said X is an element of the real numbers such that -4 is less than or equal to X, which is less than or equal to 4, right? That's what you said? Is there another way you could just say it that maybe like a child would kind of understand it? Go ahead. Yeah, Bishoy?
X is between -4 and 4.
Yeah, great. X is between -4 and 4. Any value between -4 and 4. That's what it means. That's what domain means. It can't be below -4 or above 4, but it's everything in between those, right? Good. What about range? Yep. Same thing except with y's, yeah. I know, that's what you meant. I know. Y is an element of the real numbers such that -4 is less than or equal to y, which is less than or equal to 4. Okay, good. So I hope everybody knows the notation that we're using there. Those are called brace brackets or squiggly brackets. We use those for set notation, which is like domain and range. And y is the element of real numbers such that, and then state your conditions if you have some. Okay, good. What's the next one? What kind of relationship is it? Yep. It's quadratic. What do we know? See, you already know some of this, but maybe you don't really know that you know it. But if you did well in grade 10 and you did well in grade 11 and you got some of this stuff, then you should be able to tell me something about this quadratic just from looking at its equation. That's what we're aiming for. That's what this course is about, except not just for quadratics, for all kinds of much more complicated functions. But think about that throughout the units. Is what am I learning about reciprocal functions or rational functions? And like, how is it the same as a quadratic? I know that this quadratic opens upwards because the a value is positive. I know that the base parent form of a quadratic has a certain growth pattern, has a certain look to it. And this one has the same because it doesn't have like a vertical stretch or compression, but it has some shifts or translations in different directions up and to the side or down to the side or whatever it is, right? Right. So we know some things about this just by looking at the equation. That's what we're aiming for all of these things. So this one has a shift to the right 2 and down 1. Like I said, it opens up. So from there, I can find some more points. 2, 3, 4, and give it a little sketch. And now, from the equation, I know what that guy looks like. When I'm actually looking at it on the graph, I get a sense of what it's like what it does, where the ends go. When I'm around 1, what's this guy around, right? Like I just get a visual of it. Okay, so domain and range. We already talked about this. X can be anything. X is an element of the real numbers, no restrictions. Any X value you throw at this thing, it'll give you some Y value, right? I can put anything in for X. That's what that means. But what about range?
Y is greater than or equal to -1.
Good. Such that Y is greater than or equal to -1. Y will always be bigger than -1 or -1. In other words, there's no X I can put into the equation that will give me a Y value that's -4 or -2 or -1.1 or -1 billion. That'll never happen with this function. Okay, good. What about this weird thing? This is just like, I don't know, some kind of weird mapping notation. So this is all, your first one's always like your input. And so if I put in a -3, I get out a 5. So I put in -3, I get out a 5. I put in 1, I get out 5. I put in 2, I get out a 3. I put in 5, and wait a minute. There's 2 outputs. What does that mean? Thank you. It means it's not a function. Why is that important? Because when I am doing math, like algebra, and I'm putting x's in to figure out the y's, there's nothing in the equation that can tell me which one of them I want. Right? I don't know if I want 3 or I want 6. So that makes it slightly less useful mathematically. It's a bit more ambiguous. So in mathematics, we have a word for that. It's called a function. And if something is a function, then I know I'm finding a unique y value. If it's not a function. See, again, I think a lot of these things, so I'll put in what am I doing? 5 and get out 3, put in 5 and get out 6. So I get them both. So it fails the vertical line test that's coming up, the definition of the vertical line test. It's coming up in a minute, I think, here. So there you go. That's something I think a lot of people don't think about. Like, we know the definition of a function, how to find it if it fails the vertical line test, but why is that important? I want you to think about these things. It will help you understand and remember better too. If you're doing, we don't do a lot of this, but it comes up once in a while. Sometimes it's just in the homework. Domain and range of like sets of points. So what's the domain? It's just -3, 1, 2, 5. And what's the range? The list of all possible y values. So in this case, I don't say y is an element of the real number. I don't need to say that. Y is just those 4 numbers. I list them. That's what y can be. Okay? And it's not between any of those. It's just those. Do they have to be in the right order? I don't know. Are you taught that you're supposed to write them in order? There's no rule about that. But if I was writing out 100 of them, I'd put them in order because it'd be easier to read. Find the one I'm looking for. Anyway, we don't do a lot of that. Okay, I don't know that you have to write down this definition. It'll be online if you want to. And, oh, wait. Does this even talk about the vertical line test? Where is it? Oh, there it is. Okay, so yeah, but even this one for a function is a relation in which there is a single output for each input, so unique. And as I've said, each value of the independent variable must correspond to only one value of the dependent variable. We just saw y. Are each of the following functions x equals 7? See, how do you answer a question like this? Well, I'm going to think about its graph. How would I graph that? And there you go. Like, that's why graphing is important, because you can visualize it. And you can understand something about that relationship. Is that a function? Nope. Because it looks like this. So if this is 7, it's just a vertical line at 7. I should have made that a different color. Fix that. Okay, good. What about the next one? Y equals 7. Yes? Good. So there's 7. Horizontal line that goes through 7. So this one is yes. Ooh, what about this one? 1 plus y squared equals 16. I think that's supposed to have like a plus x or something probably in there, but what if we add a plus x? Okay, so I'm going to subtract 1 from both sides. Y squared equals 15 plus x. Take the square root of both sides. And this is a little bit tricky because it looks like maybe the square root function, which you do a lot of in grade 11. But since I took the square root, I would actually write, again, this is not like, this is sort of a one-off question that's just trying to get us to think about things. This is not necessarily something that you're going to be doing a lot of, but it's plus or minus the square root of that, which means it would be back 15, and it would go like that and like that. So it's not a function because of the y squared part. Y equals x squared is a function, x equals y squared is not. But again, this highlights something. Simple algebraic skills. I subtracted 1 from both sides. Like I took this relationship that I was given and I rewrote it in a different form so that I could understand something about it. Why do you do rational expressions in grade 11? So I can take this big expression that's really ugly and complicated and simplify it to something that makes more sense, that I know something about. Now I can graph it or just understand its characteristics, that sort of thing. That's why we do algebra, right? That's why it's an important skill. Factoring, those sorts of things. Helps us rearrange and manipulate expressions so we can get more information out of it. So that's an important skill in this course for sure. Okay, as I said, to determine if something is a function or not, we put it through the vertical line test. So you can think about the uniqueness of outputs, but really, probably, I think the way a lot of people would do it is they would visualize the graph and sort of, is there ever a place where there's 2 y values for the same x? And if there's ever even 1, then it's not a function. So a little bit more review from grade 11. Again, if you haven't done math in a year, if it was last year that you took grade 11, then like you need to know all of this. Over the next few days, I'm not teaching it. I'm expecting that you know it, but that's different from, like I'm happy to answer questions if you have them. Sorry, I didn't know how you graph that exponential function. Can you go over that with me? Yes, I will. Okay, so state the domain and range. If you need to graph it, then graph it. Sketch it off to the side. Of course, that's something that you would do. If you need to think about the transformations, like what does this do? What does this do? Think about them in words. You do a lot of this in grade 11. We're going to do a lot of it in this course. Reflection in the x-axis. How does that change the characteristics of the graph? See where I'm going with all of this? Okay, so domain. You can go ahead and try it on your own if you want. What's the domain? So x can be anything. Did you get that? Like, because you know that for exponential functions, that's kind of what it always is? And did you picture the graph in your head? But you can also think, is there any value that I can put into the equation for x that won't give me a sensible answer? What if I put 0 in? What if I put 1 in? What if I put 5 in? What if I put -5? It's fine. Those are all going to work. I can take the exponent of all of those. Right? Good. Range. What's the range?
Y is the element of
Good. So y is less than or equal to 3. So exponential functions go like that, right? But this has been shifted up 3 and reflected, so it's always going to be below, and instead of always above 0, it's always going to be below, and it's shifted up 3, so always below 3. Very good. Oh, not equal to, sorry. I don't know if you said that or if I wrote that, but not equal to, right? It's never going to actually be 3, and that's very different. The point there is that's different from where up here where we looked at, say, a circle or a quadratic or anything like that, where it is equal to, compared to this one, where it's not, right? Important distinction. Okay, next one. What kind of a function is that? Reciprocal function, we call that. What's the notation for this? So not only do we have to actually think about the characteristics and properties of this function, but how do we write the notation? Because this one has a slightly different element to it, right? So x is an element of the real numbers such that, let's try this one. Somebody different, sure. Yep. X does not equal to. Good. Range. Oh, state whether or not it's a function. Yes, this is a function. Range. Y is an element of the real numbers such that. What's this one? Anybody? Hunter? You look like you want to put your hand up. Y is not 0. Very good. Even if you don't like, I will call on you sometimes just to give you a heads up. If you don't like to answer questions, I might pick on you once in a while anyway. So part of the reason for that is because I want you thinking, right? But even if you don't like putting your hand up and answering questions, you should always be trying to answer the question in your head. Don't just sit there and wait for somebody smarter than you or whatever it is you're thinking to answer the question. Try. If Mr. Belair called on me, this is what I would say. And then every time you do that, that's like a little test if you get it right or wrong when we come up with the answer, right? That challenges your memory and helps you build better memory for these things and helps you reflect on your own understanding. So make sure that you're doing that. What about this one? Oh, dear. So now we need to know a little bit about sine functions, a little bit about the a value and the k value in a sine function. So x is an element of the real numbers. For a sine curve, for a regular sine curve, it would be anything. But this says for the first 2 cycles. T, sorry, yeah, thank you. So how do I figure out for 2 cycles, where would that take me? You want to figure out the period? And there's going to be 2 of those. That's all, right? So what's the period? Period is 6. How'd you get that? Good. And so 2 of those will be, so 0 less than or equal to t less than or equal to 12. And for the range, think about your base sine curve. It goes from -1 to 1. Change the amplitude by a factor of 10. And so I get y as an element of the real numbers such that -10 less than or equal to y less than or equal to 10. Any questions about any of that? Any questions about anything else?